Okay, let's take a look at two full examples here of running a hypothesis test. Again, you may want to try this before you look at this, but let's take a look at this. Well, we have our 5 steps. Your 5 steps are always to, 1, identify the null and alternative. And in this case here, as we see, we can take a look at this claim that 80% of candidates pass driving tests. So we're saying that's the proportion. Remember, the null hypothesis always has an equals. The alternative H1 or HA, depending on your notation, right, is the proportion is, in this case, less than 80%. And again, from our sample data, we can see, right, we have 61 out of 90 and you get 0.678. That's our sample data. That's our evidence that we're going to use to test our hypothesis, right? And again, notice this here, perform a test to see if the pass rate for teens is significantly lower than the claim, and that's why we have the less than symbol. We're going to run a 1 proportion Z test, always label our procedure. Step 3 is to determine if we meet the requirements, and it looks like we do. 90, the sample 90 has to be less than 5% of all people who run the test. It's a simple random sample, randomly selected. And then it's large enough using your NP times NQ greater than 10. So now that we have that, the next step, right? So those are the first 3. Once that's cleared, we do the test statistic. We have the formula and we substitute in. 80-20 come from your p-value, and your q is 20%. 1 minus, right? Remember, that's that relationship. The 90 is the sample size, and you get negative 2.89. After you have your p-value, you calculate the test statistic. And so over here, right, using StatCrunch or ArtiStat, you would take the probability that z is less than negative 289. Remember, that value is the measure of how many standard errors your sample data is from our claimed value of 80%, or 0.80, right? And so we get this number, and it's a low value, and that goes back to, right, do we have statistically significant evidence? Now, once we now have our 4th step, the value, we come to step 5, which is come to a conclusion, right? Since the p-value is less than 0.05 right here, which is normally, there was no alpha stated here. And so since if there is no alpha stated, right, we're going to use alpha 0.05. That's our usual value. We reject the null hypothesis. And so that's why I have a little x here. We're rejecting that, which means we're accepting that. Then this, again, there is sufficient evidence to support the claim, right? The alternative hypothesis, that the proportion is less than 80%. And so because the p-value is low, statistically significant, can't spell, okay? And so there's an example there. You can pause and take a look at that. And then looking at one more example here, again, running through a whole test, we'll see again, we have a claim that 60% of graduates are prepared to manage their own finances. We get a sample. Is there evidence that the proportion of graduates has changed? So that would be P is not equal, that it's changed. It can be greater than or less than, so we say not equals to. Again, this is a 1 proportion Z test. We're going to check the requirements, right? 500 is probably less than all graduates in the country. It's large enough, right? We can do that P times Q. It's greater than 10, obviously. Now, it doesn't say how, out of a sample of 500 graduates, it doesn't say if it was random. So we're not sure on this. So we're going to just assume it is and then continue because we want to run the test. But in real life, we would have to say, you know what? We don't have that. So we may not be sure, right, confident with this conclusion because we don't know if it's a random sample or not, okay? But we're going to still do it. Our sample evidence in this case is 327 out of 500. So it looks greater than. It looks like we do have some evidence, but we got to run the test to verify that. Like, is this number far enough away from 60, 0.60, for us to say that it is statistically significant? And so in this case here, we calculate the p-value. And in this case, since it's a not equal, we call this a two-tail test. And so we're going to end up calculating the probability that z is greater than 2.46. It's a two-tailed test when it's not equals. I forgot to mention that up here. Since it was less than, it was just a left tail. We just calculate that one probability. Two tail, we got to calculate both probabilities from this test statistic. And then we end up with the probability of z greater than 2.46 or z is less than negative 2.46 is 0.0137. Again, you're going to do that in StatCrunch and you're going to get this answer. You can do one and they're going to be the same. They're symmetric, so you get the same answer. So that's why you see 2 times just one of them. But if you do them, you would add them together technically to get this. And this value is low. We don't have an alpha here. So in this case, since we don't have an alpha, we're not given an alpha, we're going to use alpha 0.05 when it's not given. Okay, we assume that. And so we reject the null hypothesis. So we're saying that's not, and we'll accept that because it's less than 0.05. And again, we're going back to this over here. In our last conclusion, it's statistically significant. And then we come to the conclusion of there is sufficient evidence to conclude that the percentage of graduates who are prepared is not 60%. So our evidence, our data is statistically significant. Sorry about the writing, a little sloppy, but that's it.